Today I am going to explain motion in plane chapter NCERT textbook numerical questions. So here observe the first question for today's class. Three girls skating on a circular ice ground of radius 200 meters start from a point P on the edge of the ground and reach a point Q diametrically opposite to P, following different paths as shown in figure 4.20. What is the magnitude of the displacement vector for each? For which girl is this equal to the actual length of path skate? Observe the diagram here. Starting point is P and ending point is Q. Path A, path B, and here path C. Three girls were moving from P to Q along the three different paths. For all the three paths, path lengths are different. But here what is asking in this question? What is the magnitude of displacement vector for each? What is the meaning of displacement? Displacement is final position minus initial position or shortest distance between final position and initial position. See, for all the three paths, path A, path B and path C are girl A, girl B, girl C. For all the three girls, path lengths may be different, but displacements are equal for all the three girls. That is equal to, so displacement, see here, so displacement is equal to PQ, shortest path, or path length of B girl, path length of girl B, path length of girl B, that is diameter, or radius. See in the question 200 meters is given radius, so therefore 2r is the shortest distance or path length for B, that is 2 into 200 or that is equal to 400 meters. 400 meters is the shortest distance between the final position and initial position, or it is also called displacement. And this displacement is same for all the three girls, A, B and C. And for which girl path length is equal to displacement here? For B. So second one is for girl B, path length is equal to displacement. Path length is equal to displacement. So this is the two answers for this question. See students, please try to understand clearly, and if you have any doubts in these questions or today's class, I will clarify your doubts later. So in our regular classes. Okay. Please try to note down these solutions and try to understand carefully. That is most important. Okay. Now I will move to the next question. See the question 2 for today's class. It is also a simple question. First read the question. A cyclist starts from the center O of a circular park of radius 1 kilometer. See here radius is given 1 kilometer. Reaches the edge P of the park. Then cycles along the circumference and returns to the center along QO as shown in figure 4.21. If the round trip takes 10 minutes, what is the net displacement, B, average velocity, and C, average speed of the cyclist? That is the question. Observe the diagram. Cyclist starts at O of the circular park. O is the radius, center of the circular park of radius 1 kilometer. And first cyclist moves to P along radius, OP. O to P, then P to Q along the circumference of a circle, P to Q, and finally Q to O. So it means initial position is O and final position is also O. So therefore net displacement is 0. The cyclist starts at O, travel to P, and then P to Q along the circumference of a circular path, then Q to O. So that first A answer. Solution for A, net displacement. Net displacement is equal to 0. What is the reason for this? Initial position and final positions are same. Displacement definition ಏನು? Shortest distance between final position and initial position is called displacement. Here final position O, initial position is also O. Therefore, net displacement is 0. Next, what is the B question here? Average velocity. Average velocity. Average velocity is equal to net displacement. Net displacement divided by total time. What is the total time given in the question? Total time given in the question is 10 minutes. 10 minutes. So 0 by anything. 0 by anything is equal to 0. So average velocity is equal to 0 because net displacement is equal to 0. Why net displacement is 0? Initial position is O, final position is also O. Next, C. Average speed. Average speed is equal to total distance traveled. Total distance or path length. Total distance traveled by total time. Total distance traveled by total time or total path length. What is the total path length here? It's a numerator. First O to P plus PQ along the circumference plus QO divided by 10 minutes. So 10 minutes can be converted into hours. So 10 by 60 hours. 10 by 60 hours. 10 minutes is given T. So T is equal to, time is equal to 10 minutes is given. If it is converted into hours, so 10 by 60 hours. 10 by 60 hours. OP is equal to radius. But OP is equal to, OQ is equal to R, that is equal to 1 kilometer. And what about PQ here? PQ is quadrant of a circle. PQ is quadrant of a circle. Quadrant of a circle andre enu? 1 by 4th of perimeter. That is the meaning. PQ is equal to 1 by 4th of perimeter. Perimeter of a circle. 1 by 4th of perimeter of a circle. Circumference of a circle. So here 2 1s are 2 2s are. That is pi r by 2. So therefore, average speed V average is equal to 1 kilometer plus pi by 2 into r. R is equal to 1 again, and OQ is equal to r. So that is equal to 2 plus pi by 2. 1 plus 1 2, pi by 2 into 1 is pi by 2. Pi by 2 is 20, pi value 3 point approximately 3.14 by 2. Pi andre 22 by 7. Pi is equal to 22 by 7. 22 by 7 is equal to 3.14. So here 2 ones are 2 ones are 2, 11 remaining. So that is 2 5s are 10, 2 7s are 14. So 1.57 plus 2, that is equal to 2.57 2.57 kilometers. 2.57 kilometers. This is not V average divided by time. Here whole divided by time is 1 by 6 hours. So here whole divided by 1 by 6 hours. Here also whole divided by 1 by 6 hours. So that is equal to 1 by 6 hours. 1 by 6 hours. So please multiply this 2.57 into 6. 15.42 kilometers per hour. Students, please note down this. See, 2 plus 1.37 is, this is 3.57. So not 2.57, please correct it. 3.57 into 6, that is 21.42 kilometers per hour. 21.42 kilometers per hour. Next question. Read the next question. On an open ground, a motorist follows a track that turns to his left by an angle of 60 degrees after every 500 meters. Starting from a given turn, specify the displacement of the motorist at the third, sixth, and eighth turn. Compare the magnitude of the displacement with the total path length covered by the motorist in each case. So here, after every 500 meters, the motorcyclist turns by. So I can draw the diagram here. First, let us take PQ. PQ is 500 meters. After every 500 meters, he takes a turn of 60 degrees. He turned by 60 degrees. Again 500 meters traveled. Then again he takes a turn of 60 degrees, and here 60 degrees. So it is a regular hexagon. We will get a regular hexagon because the motorcyclist takes after every 500 meters he turned left by 60 degrees. This is the situation. So all these sides PQ, R, S, T, U, and let us take here center of the regular hexagon is assumed as O. Center of the regular hexagon is taken as O. Yes. Now, as per the question, on an open ground, a motorist follows a track that turns to his left by an angle of 60 degrees after every 500 meters. Okay, let us assume that starting point is P. If we assume starting point is P, this is first turn at Q, second turn at R, third turn at S, fourth turn at T, the fifth turn, sixth turn again at P, and here it is seventh turn. Then at R, eighth turn. Okay, third, sixth turn and eighth turn we should find out. First of all, third turn. Third turn means first at third turn. At third turn, that is at S. Starting point is P. Let us assume that starting point is P, and first turn, the person takes a turn left by 60 degrees after every 500 meters. That is the question. So P to Q 500, here P to Q is 500 meters each side. Each side is equal to 500 meters. A regular hexagon it is. Every side, after every 500 meters distance, he turned left by 60 degrees. That is the question. So first turn is at Q, second turn is at R, third turn is at S, third turn is at S. So up to S, between P and S, between P and S. So we should find out each and every time, compare the magnitude of the displacement with the total path length covered by the motorist in each case. Displacement to and path length. Andre path length is nothing but distance. Displacement and distance. Displacement to and distance, we should find it out. In the first case, path length, total path length. So total path length is equal to up to third turn PQ plus QR plus RS. That is equal to 500 plus 500 plus 500. So that is equal to 1500 meters. This is the path length up to third turn. From starting point to third turn, path length is 1500 meters. 1500 meters. Next, displacement. Net displacement. So net displacement S is equal to PS bar in the diagram. PS bar in the diagram. PS bar in the diagram. So PS bar andre, it is the twice, that is equal to PO plus OS. PO also equal to 500 and OS is equal to 500. So therefore 1000 meters. 1000 meters is the displacement. 1000 meters is the displacement. Shortest distance. Displacement andre shortest distance. PO plus OS. Next, sixth turn. Second one is at sixth turn. Sixth turn means at P. So for 6 turns, he will come back to the starting point. Come back to the starting point. Starting point here, final point and initial points are same. So therefore, displacement. So displacement S is equal to 0. Because sixth turn, count it. 1, 2, 3, 4, 5, sixth turn. at 6 turns, the motorist coming back to the starting point. That is at 6th turn, while he is taking 6th turn, he is at the initial position. So that final position, initial positions are same. Final position and initial positions are same. So therefore, displacement, net displacement at 6th turn is equal to 0. Then total path length. Total path length andre total circumference or perimeter of the regular hexagon. And next, total path length at 6th turn. Total path length. Total path length is equal to PQ plus QR plus RS plus ST plus TU plus UP. That is equal to, all are equal to 500. 500 plus 500 plus 500 plus 500 plus 500. So that is equal to total 3000 meters. So distance or path length up to 6th turn. Path length up to 6th turn is 3000 meters. Displacement at 6th turn is 0, because this is at 6th turn, by the 6th turn, 6 times of turning, he came back to the original position. Next one is 8th turn. 8th turn. 8th turn means, count it. P is the 6th turn, Q 7th turn, R 8th turn. That is at R. 8th turn means at R. What is the displacement here? Displacement is PR. And distance, first we can find out the total length. Total path length. Total path length up to 8th turn. Total path length up to 8th turn. Circumference of the hexagon. Circumference of the hexagon plus PQ plus QR. So that is equal to, circumference is 3000. 3000 meters plus 500 plus 500. That is equal to total 4000 meters. Path length up to 8th turn. Path length up to 8th turn. Now displacement. Net displacement at 8th turn is PR. Observe here in the diagram, P, O, R, Q is a parallelogram from O or P, O, R, Q, parallelogram. Here this 60 degrees and here 60 degrees, same angle. That is two vectors. PQ is one vector, QR is second vector. Between PQ and QR, angle between the two vectors is 60 degrees, and resultant makes an angle. So resultant S, let us take as S bar. Resultant S bar is making an angle alpha with the first vector PQ. Okay. So according to the parallelogram law of vector addition, we know that S bar is equal to square root of PQ square plus QR square plus 2PQ into QR into cos 60, because angle between first vector and second vector is 60 degrees here. Angle between first vector and second vector, observe the parallelogram PORQ parallelogram. that is equal to PQ is 500, 500 square under root square root of 500 square plus 500 square plus 2 into 500 into 500 into 1 by 2. So here 2 cancel, that is equal to square root of 500 square plus 500 square plus 500 square. That is 3 into 500 square, or that is equal to 500 root 3. 500 root 3. So root 3, we know the value root 3, 1.372 into 5. 1.732 into 5. This can be written as 5 root 3 into 100. So 5 root 3 is 8.66 into 100, or that is equal to 866 meters. Next, direction. We also know that alpha is equal to tan inverse of 500 sin 60 divided by 500 plus 500 cos 60. Formula is tan inverse of q sin theta divided by p plus q cos theta is the formula. So that is tan inverse of cos 60. Cos 60 is equal to root 3 by 2. So root 3 by 2 into 500 divided by 500 plus 500 by 2. Cos 60 is equal to 1 by 2. So that is tan inverse of 250 root 3 divided by, see here 500 plus 250, that is 750. So this is 3, root 3 by 3, root 3 by 3 is equal to, root 3 by 3 is equal to 1 by root 3. Tan inverse of 1 by root 3. 1 by root 3 can be written as tan 30. So alpha is equal to tan inverse of tan 30. So tan cancel, that is equal to 30 degrees. So displacement at 8th turn. Displacement at 8th turn is 866 meters, and direction of displacement is 30 degrees with a PQ. 30 degrees with PQ is the direction. Next question. Read the next question. A passenger arriving in a new town wishes to go from the station to a hotel located 10 kilometers away on a straight road from the station. A dishonest cabman takes him along a circuitous path 23 kilometers long and reaches the hotel in 28 minutes. What is the average speed of the taxi and the magnitude of average velocity? Are the two equal? See, average a dishonest cabman takes him, a passenger, him the passenger, along circuitous path. Actually, shortest distance between the hotel and station is 10 kilometers only. But instead of that 10 kilometers, the dishonest cabman takes him along a circuitous path of total length 23 kilometers. So that here, average first A, average speed. Average speed is equal to total distance or total path length. Total distance divided by total time. Total distance by, what is the total distance here? 23 kilometers. Total time is 28 minutes. But if it is converted into hours, 28 by 60. 28 minutes. To convert it into hours, we should divide the given value with 60. So that is equal to 23 into 60 divided by 28 kilometers per hour. The average speed is equal to 23 into 60 divided by 28. 1380 divided by 28, that is 49.28, or it is approximately 49.3 kilometers per hour. Okay, next, second, B, magnitude of average velocity. Average velocity. Average velocity definition is total displacement, net displacement. Net displacement divided by total time. Net displacement by total time. What is the displacement? Is nothing but shortest distance between the station and hotel. What is the shortest distance given in the question? 10 kilometers. So therefore, net displacement andre shortest distance. So 10 kilometers divided by time same we should consider as 28 minutes by 60 hours. So that is equal to 10 into 60 divided by 28, or that is equal to 600 by 28 kilometers per hour. So that is equal to 600 divided by 28. So it is 21.42 kilometers per hour. See, in this question, average speed is equal to total path length by total time. Total path length is given 23 kilometers. Time 28 minutes. Average velocity andre shortest distance between hotel and station. Shortest distance is given 10 kilometers. So the 10 kilometers by time 28 minutes. Next question. Rain is falling vertically with a speed of 30 meters per second. A woman rides a bicycle with a speed of 10 meters per second in the north to south direction. What is the direction in which she should hold her umbrella? See, in this question, rain is falling vertically downwards. Rain is falling vertically downwards with velocity Vr. And see here, a woman rides a bicycle. Cyclist is moving from north to south. Let us, for convenient, let us take this horizontal line is north to south. North to south with the cycle Vc. Let us assume that Vc is the speed of a cyclist. Vc is the speed of a cyclist. So umbrella should hold in a direction of relative velocity of these two. Vr, velocity of rain, speed of rain or rain falling, and Vc is the velocity of cyclist. Umbrella should hold. Umbrella should hold in a direction of relative velocity. What is relative velocity here? So relative velocity VRC is equal to VR minus Vc. That is the relative velocity. VR minus Vc. So Vc is, if it is acting towards south, minus Vc. This is the minus Vc direction towards north, minus Vc. So VR is acting downwards. VR is acting downwards. VR is one vector, minus Vc is another vector. So this can also be written as VR plus minus Vc. Addition of two vectors. One vector is rain velocity. Another vector is cyclist, speed of cyclist in north side, towards north, minus Vc. So therefore, relative velocity, this is the relative velocity, making an angle theta with vertical. Relative velocity direction. So this is the relative velocity. In this direction, umbrella should hold. That is with south, some angle theta. That is, see, now according to parallelogram law of vector addition, we want only direction. So here theta or alpha or anything. We should find out theta. VR is velocity of falling rain, velocity of falling rain, and VC is the velocity of cyclist, velocity of cyclist. So what is VRC is equal to, VR is given in the question 30, 30 plus minus 10, that is equal to 20 meters per second. Relative velocity between rain and cyclist is 20 meters per second. And next, tan theta is equal to direction. To know the direction, tan theta, what is opposite side here? VC. VC is the opposite side to theta. VR is adjacent side. VC is 10, VR is 30. That is 1 by 3. Or theta is equal to tan inverse of 1 by 3. So that implies theta is equal to tan inverse of 0.333 like this. It is approximately 18 degrees. So that is, the woman must hold the umbrella towards the south at an angle of 18 degrees. Nearly 18 degrees with a vertical. Okay. Next question. I will move to the next question. See, read the next question. A man can swim with a speed of 4 kilometers per hour in still water. How long does he take to cross a river 1 kilometer wide if the river flows steadily at 3 kilometers per hour and he makes his strokes normal to the river current? How far down the river does he go when he reaches the other bank? First, understand the question and you can able to draw the diagram for the question. When we able to draw the diagram, the question is turned into representation. So let us take here, river is flowing from left to right. River is flowing from left to right with a speed of 3 kilometers per hour. VR is equal to 3 kilometers per hour. River is flowing with 3 kilometers per hour. And now a person swims. See, a man can swim with a speed of 4 kilometers per hour in still water. How long does he take to cross a river 1 kilometer wide if the river flows steadily? So he makes his strokes normal. So in this direction, normal to the river flow. Let us take from P to Q. But instead of reaching exactly the opposite point Q, he may reach to some other point because of river flow. Due to river flow, he can reach to some other point R. What is that QR? This is asking. What is the QR? First, we should estimate the time taken to cross the river. Speed of the man. Speed of a man, Vm is equal to 4 kilometers per hour. Speed of a man, Vm is equal to 4 kilometers per hour. And width of river is also given. Width of river, so D is equal to 1 kilometer is given. This is a 1 kilometer. Width of river is 1 kilometer. 1 kilometer is given. So therefore, time taken to cross a river, T is equal to width of the river by speed of the man. width of the river by speed of a man. So that implies T is equal to 1 kilometer divided by 4 kilometer per hour. Kilometer cancel, hour goes to the numerator, 1 by 4 hour. 1 hour is equal to 60 minutes by 4. 60 by 4 andre 15. 15 minutes. So man can take 15 minutes. 15 minutes time to cross the river. So distance moved. Therefore, in this time, in 15 minutes, distance moved or drifted. Distance moved along downstream. Distance moved along downstream, that is QR. QR is equal to speed of river into time. Due to the speed of river, man can move displaced to R instead of Q. Actually, he wants to reach the exactly opposite point, that is from P to Q. But instead, due to the river flow, he instead of reaching the point Q, he may reach to some other point R along the downstream. So how much distance he can drifted? QR. So that implies QR is equal to 3 into 15. 3 kilometers, this is 60. 15 by 60 hour or 1 by 4 hour. 3 into 3 kilometers, 3 kilometers per hour by 4. 3 by 4 andre 0.75. 0.75 kilometers per hour, but 1 kilometer is equal to 1000 meters. So therefore, this can be written as 750 meters. 750 meters. Distance is not kilo. Distance. Kilometers by hour per hour is cancel. Hour cancel here. 750. See, listen students, once again this question. Person starts at one end of the river, one bank of the river, and he wants to reach to opposite end. For that, he swim across the river normal to the river flow. Normal, he started normal to the river flow. That is mentioned in the question. He makes his strokes normal to the river current. But due to the flow of river, instead of reaching the point Q up on opposite bank, he reached to some other point, say R, some other point R. So how much time, first of all, how much time he will take to cross the river? The time is equal to width of the river by speed of the man. Width of the river by speed of the man. So that is 15 minutes or 1 by 4 hour. 1 by 4th of an hour. That is the time. In that 1 by 4th of an hour time, how much distance he moved along the downstream? Along the downstream. That is distance is equal to velocity of river into time. So 750 meters. Read the question. In a harbor, wind is blowing at the speed of 72 kilometers per hour and the flag on the mast of a boat anchored in the harbor flutters along the northeast direction. If the boat starts moving at a speed of 51 kilometers per hour to the north, what is the direction of the flag on the mast of the boat? Here first can write down the given values. Velocity of the boat, given data. Velocity of a boat. So let us take VB. VB is given 51 kilometers per hour. 51 kilometers per hour. Velocity of wind. Velocity of wind is given. So this we can assume as VW. What is given? VW is equal to, so 72. VW is equal to 72 kilometers per hour is given. Okay. Now, when a boat is, See, in a harbor, wind is blowing at a speed of 72 kilometers per hour and the flag on the mast of a boat anchored in the harbor flutters along the northeast direction. If the boat starts moving at a speed of 51 kilometers per hour to the north. Okay. Now you can draw the diagram. So north, towards north. Boat is moving towards north. And the directions, this is east direction. Boat is moving towards north with a velocity b, with a speed b, and uh, flag flutters in the northeast direction initially. Northeast direction. This is a NE direction. Flag on the mast of a boat. When boat starts moving, definitely this flag flutters in this direction, opposite to the direction of the motion of a boat. So any direction. Now we should find out this total initial. This is we can take it as to know the relative velocity. Wind velocity. Wind is blowing in northeast direction. A flag flutters in the northeast direction means wind also blowing in the same direction. So this is VW. VW. The harbor flutters the flag on the mast of a boat anchored in the harbor flutters along the northeast direction. It means wind is blowing in northeast direction. So relative velocity concept. To take the relative velocity, we can take it as angle between VW, wind velocity, and minus VB. Minus VB is northeast, and this is 45 degrees. 45 in parallelogram law of vectors. Now, one vector is VW and second vector is VB. Second vector is VB. VB, and we know that according to, so when boat is at rest, listen students carefully, when boat is at rest, flag is fluttering in the northeast direction. That is original direction, northeast direction. When boat starts moving, in which direction flag flutters? That is only the thing here in this question. So we know that alpha is equal to, according to parallelogram law of vector addition, second vector into sine theta divided by first vector plus second vector into cos theta. This is the formula for direction, resultant vector direction. So alpha is equal to tan inverse of, what is second vector here? VB. VB 51, theta 135 or 90. You can write it, it is convenient. For 90 plus 45 is convenient. Sin 90 plus 45 divided by 72 plus 51 cos 90 plus 45. That is equal to tan inverse of 51. Sin 90 plus 45. 90 plus andre second quadrant. In second quadrant, sin is positive. So that 90 angle is there, odd angle. That's why it is cos 45. Sin 90 plus 45 is equal to cos 45. And cos 90 plus 45 is minus sin 45. So in second quadrant, cos is negative. In second quadrant, cos is negative. That implies tan inverse of 51 into 1 by root 2 divided by 72 minus 51 into 1 by root 2. That is equal to tan inverse of 51 by root 2 divided by 72 root 2 minus 51 whole divided by root 2 denominator. 1 by root 2, 1 by root 2 cancel. 1 by root 2, 1 by root 2 cancel. See here, alpha is equal to tan inverse of 51 divided by 72 into 1.414 root 2 value minus 51. First, can simplify the denominator value, that is 72 into 1.414, 101.808 minus 51. So 50 point. So alpha is equal to tan inverse of 51 divided by 50.808, almost 1 but not equal to 1, almost 1. 51 by 51 almost. Tan inverse of 1 is 45 degrees, but little higher value is there in denominator. Little higher value is there in denominator, so that it is little higher than 45 degrees. Little higher than 45 degrees. So alpha is equal to tan inverse of 1.0038, or this is approximately 45.11 degrees. 45.11 degrees. So it means when boat is at rest, flag on the mast of a boat flutters in northeast direction. When boat starts moving with velocity Vb, the flag flutters in a direction 45.11 degrees with northeast, or 0.11 with east. 45.11 degrees with northeast, or 0.11 degrees with the east direction. 0.11 degrees with the east direction. Okay, students, thank you very much. I will end the session here.